Hey folks, I'm Mr. Hartzler here for Hartzler University. I want to talk to you today about logarithmic functions, and let's go take a peek at our target. Alright, so our target for today is that I can graph logarithmic functions and find equations of the inverses of both exponential and logarithmic functions. So let's go get started. Here, I first want to discuss the parent function. Right, it's this one over here on the left. And it is important to note that b here doesn't do a whole lot except make it either more or less steep. The h, it does what you would always anticipate. It does the horizontal translations, right? It shifts it left and right. And then the k does the vertical stuff. So that's what shifts it up and down. And for our main log, for all of our logs actually, regardless of b, I like to talk about our home base. So for an exponential function, it is at 0, 1. But for logs, it's at 1, 0. So it is this point right there. And then again, b will just determine how steep this thing is. But I look in general like, well, that's a terrible one. Let's give that another go. All right, so this time let's try it again. Here we come up, up. Awesome. This is what this graph looks like in general. I have an asymptote on my y-axis. I cannot cross my y-axis. And again, I cross at this point right here at 1, 0. My domain for all of this, right, is, again, asymptote on the y-axis. So I'm everything greater than that. So that means x has to be greater than 0, not equal to, strictly greater than 0. Then let's look at our range. Well, it keeps going down. It doesn't look like it keeps going up, but it does keep going up and to the right, but mostly right, but it's still up. So that is actually going to be all real numbers, with which is a cool r, or I could write negative infinity, comma, infinity. And again, that b value will make it more or less steep. And what I mean by that is it would be either further inside if b was greater, and it would be farther on the outside if b was less than whatever number we were talking about there. Okay, let's go over and look at our graph on this other one here. It's a quick little example. We're going to leave that as a 2, so log base 2 of x equal or minus 1. So instead of being here, our normal home base, we're shifted down 1. So now I'm here. And we come up, up, and turn. I'm a little bit off my dot there, but I'm going to do an old trick. Make my dot bigger. It's perfect. There we go. And again, this would be steeper, so it would turn sharper to the right if it were a larger number there. And it would turn less sharp if it were a bigger number, or sorry, if it was a smaller number there, until it hits the point where it becomes less than 1, and then it changes and actually opens up that bottom way. But let's keep going, look at more examples. All right, so the translations here, right? Still have a 2, nothing too impressive, nothing too exciting. Then here we have this 3, so we're shifted opposite of what you would think. So left 3, and this one means I go up 1. All right, so left 3. Remember, that is my home base, so I'm going 1, 2, 3 to the left, and 1 up puts me here at negative 3 and up 1. And then from there, what does this graph do? Well, it goes 1 over here and comes up, and then it turns. In this case, my asymptote was also shifted to the left 3, so I have an asymptote right here. Hopefully you can see that. But it goes right there at x equals 3. All right, that's what my graph looks like. My domain is, in this case, a little bit different now because x has to be greater than negative 3 because I was shifted left 3. My range, still all real numbers, and I could also write that as negative infinity to infinity. Now this one down on the bottom, what's going on here? This 20 means I'm stretched a little bit. It's a sharper right turn. This one means I go right 1, and this 2 means I go up 2. Let's clear off this graph and let's do a new one. All right, so now we're all cleaned up here. Let us move this graph, right? We usually start at 1, 0, but I'm shifted to the right 1 and up 2. So I'm here now. What happened to my asymptote? It was shifted to the right 1, so it's now here at x equals 1. And we know that this is sharper, right? That 20 is a sharper angle. So I'm going to come up and boom, hit it and turn real hard. It actually looks like it goes down a little bit, but it doesn't. It's just a real sharp turn compared to some of the other ones that we've had. All right, in our domain, you can still see that. Yeah, you can still see that. Our domain is similar to the last one, right? I'm shifted to the left 1, so x has to be greater than 1. My range is still negative infinity to infinity. Sweet. Let's go to the next one. Now we're here. This one's a little more tricky. I'm finding inverses of exponential and of log functions. So start off with the inverse of this chunk here. My first step is to switch my x's and my y's. So now it's, instead of f of x, it's going to be, which is also called a y, I'm switching my x's and y's. So it's x equals 3 to the y plus 2. Okay, well, I need to solve for y, and that's hard to do as an exponent. The trick then is to convert this from exponential form into log form. So I have a log. What is my base there? So what exponent on, well, what thing has an exponent? 3. So what's the exponent on 3 that gets me this value? So that's an x. Okay, so what exponent on 3 gets me x? Well, that exponent is y plus 2. This comes with a little bit of practice. Check yourself now by doing that little looping technique I've shown you in the past. 3 raised to this power equals x. Okay, that's true. That was what we originally had. What exponent on 3 gets me x? Okay, what exponent on 3 gets me the x? Well, that's this thing, so that's why it's all by itself. Okay, then I have to subtract the 2, so I'm getting y by itself. Now I have a y by itself. That equals log base 3 of x. Then I subtract 2. Those are separate things. This is not an x minus 2 all inside the log. That minus 2 is outside the log. And then I replace that y with my inverse function, right? F to the negative 1 of x. So these two things, this up here and this down here, are inverses. So they undo each other. They cancel each other out. And this is a graph shifted down 2. So my domain is unchanged. My asymptote didn't change, so it's still x is greater than 0. I wasn't shifted left or right any. My range, doesn't matter what happens there, it's still going to be negative infinity to infinity. Awesome. Now let's go down and let's find the inverse of this one. Okay, so again, that's like a y, but I need to switch my x's and my y's. So this is now x equals log base 5 of y minus 1. I'm kind of doing a reverse PEMDAS thing first, right? I'm going to add 1. So x plus 1 equals log base 5 of y. I need to get my y outside of my log. And I can't divide by a log. Remember, it's a function. Log base 5 of y. Just like f of x. I can't divide by f to get rid of it. So I'm going to actually go from log form into exponential form. Kind of the opposite of what we did a second ago, right? So 5 raised to the x plus 1 power equals y. My log is gone now, right? That's what happens when I go from log form into exponential form, is I don't have a log anymore. So 5 to the x plus 1 equals y. That is my function. Oh, don't write a y though. Remember, it's f inverse now. F inverse of x equals, I'm just going to rewrite it here, x plus 1. Awesome. How cool is that? That's an exponential growth, and it's shifted to the left 1. Let's do a quick review of that. I usually cross right there at 0, 1. I'm shifted to the left 1, so here. And exponential growth, because it's a 5 and not a fraction. Sorry, not a number less than 1. So I look something like that with an asymptote on my x-axis, which means my domain is all real numbers. And my range is y greater than 0. Okay, very, very cool. And let's check next one. We're done. I hope all of you have a great rest of your day. Make sure you subscribe to this channel, right, and click that little bell so you can get notifications when I put up new videos. If this was helpful, make sure you click that like button, and I hope all of you do math carefully and with enthusiasm. Bye, everybody.